Hello everyone, and thank you so much for joining me on our first video about circles. I'm going to start this video looking at different definitions. So the note page you have in front of you is actually a doodle page. So as I talk about the definitions of the circles and the parts within them, you can just kind of doodle along, color it, label it how it makes sense to you. I've got a whole bunch of colors here that I'm going to use. So let's get started. So we're looking at all the different parts of a circle. Well, did you know that the word circle comes from Latin, and that word was circulus, and that word means disc. So the study of circles has been around for a long time, okay? Well, here's a couple things that we need to do, some things to do over here. First, we want to label a sector. A sector of a circle. I'm going to get a color here. I'm going to go with blue. A sector of a circle is like a wedge out of the circle. It's just a portion of the total area within a circle. So this zone over here that I'm doodling in blue, this is the sector of the circle. The next thing that we need to label is a segment of a circle. And a segment of a circle, I'm going to highlight it here in pink. A segment of a circle is like if you were to just cut off a portion of the circle. Okay, so we have a sector of a circle, which is like a wedge that comes from the middle of the circle. And then we have a segment of a circle over here, which comes from using the cord to cut through the circle and cut off a piece, okay? All right, next thing I want to talk about here is, it says to draw an arrow that shows that the circumference goes all the way around a circle. So here's our circumference down here in yellow, and the circumference is the distance all the way around the circle. It's like the perimeter of a circle. Okay. Next on our list, it says to label the center of our circle. And the center of your circle is this dot right here in the middle, and it's just labeled as a point. So I'm going to call this circle B. You can call it whatever you want. There is the center of our circle. All right, and then there's some other formulas here before we move on down to the bottom to complete all the different definitions. There's a couple other things here to check out. These are all words that I'm pretty sure you've heard before, maybe a few new ones. So let's check this out. We've got, we just talked about the center of the circle. We also have the radius of the circle. I'm going to highlight it in orange over here. And the radius just starts at the center and it moves its way out to the outer edge. So I'm pretty sure you're familiar with a radius. There's the radius of the circle. Another part that we need to be familiar with is called the diameter of the circle. And the diameter of the circle goes all the way across. I'll color that one in green. The diameter goes all the way across from corner or from side to side, and it has to go through the center. So that's why this diameter is going through B. All right. If you have other lines that are cutting through your circle, they have other names. So these are less frequently used lines, but they do have other names. Here we've got, let's see, I guess I'll highlight this one. I'll go with blue. We've got a secant line versus, there we go, versus a chord. Now there's a very slight difference between a secant and a chord. So let's see if you can see the difference. A secant has these arrows on the end, which means it's a line. It goes on forever and ever and ever and ever and ever. A chord does not have arrows on the end. It stops right on the edge of the circle. And that is the only difference between those two things. And then finally, our last piece here is this tangent line that's just hanging out on the side. A tangent line, you heard that word tangent when you were in your trig unit, but a tangent line just skims by the edge of the circle, and it only hits it in one point. That point is actually called the point of tangency. So there's your tangent line. Now throughout the unit, ooh, my phone's making crazy noises. So throughout the unit, you're going to hear us use all of these terms. So I just wanted you to have a good visual to start with. I'm going to pause the video. I'm going to color my words to match the picture. Okay, so now that I have colored my picture, everything has a match to it. I can clearly see my vocab words, and this is a picture that I'm going to be able to remember as I go throughout the unit. I'll just envision this picture. As vocab words pop up, I'll be able to see it because I've labeled it and I've colored it. I did notice while I was working that I left out a word, and it's hiding right here. So let's hit this one real quick. We've got an arc over here, and this arc, this word, has just a teeny tiny little space that it's indicating, and that's just a little piece of the entire circumference. It's the little edge piece of the entire circumference is called the arc. Now you can have really big arcs. I mean, check out this arc over here on the circle. On the sector of the circle, or this large arc down here on the segment of the circle, or you can have smaller arcs, okay? All right, so our next challenge here is to complete the definitions below. So as we complete these definitions, now we have a visual to look at, so we can do kind of a match here. All right, our first definition says a line segment that passes through the center and has endpoints on the circumference. So let's check that out. A line segment, that's important. That means it stops. It doesn't have arrows on both ends. So it's not a tangent and it's not a secant. Segments would be like a radius or a diameter or a chord. Okay, it passes through the center, so that takes out chord, and it has endpoints on the circumference, which means it can only be a diameter. Endpoint on the circumference here and here. The radius has an endpoint at the center. So this is a diameter. I'm going to outline it in green so that I'll know they all go together. The more colors I get in there, the more I can remember. Okay, next. Let's see. Another line segment, a line segment that has both endpoints on the circumference. So it's almost just like this one we just did, but it doesn't include the part where it says it has to pass through the center. So it's another line segment, but it does not have to pass through the center. So it would have to be a chord. Both endpoints are on the circumference of the circle. Okay. Next, a portion that's defined by a chord and an arc. A portion that's defined by a chord and an arc. So look, it's defined by the chord. Let's go find that chord. Here's the chord. And remember, an arc is along the edge of the circle, along that circumference. So defined by the chord and the circumference out here, we're highlighting the segment. A segment of a circle. Okay. Let's slide down here a little bit. Next, We have another line segment that has one endpoint at the center and the other endpoint at the circumference. One endpoint at the center and the other endpoint at the circumference. We're going to be talking about the radius here. The radius starts at the center and travels and connects to the circumference. Right, so I think we've got all of our segments done now. The first one we mentioned was the diameter, goes through the center and connects on the circumference. Then we talked about the chord. It connects on the circumference of the circle, but does not go through the center. And now we've talked about the radius, which is at the center, one endpoint, and to the circumference of the circle for the second endpoint. All right, let's see if we missed anything else here. All right here in the middle, a line segment, oh, maybe I'm wrong, a line segment that touches only one point on the circumference. A line segment that only touches one point on the circumference. Well, I think I already disagree a little bit with this definition. Let's take a look at our picture. Only touches one endpoint on the circumference. That's going to be your tangent, the tangent that just skims right on by. And a tangent could be a segment, but it also could be a line. So I think what I'm going to do to this definition is that I'm going to put a slash in there. It's a line or a line segment. It could be either one. So it's a line or a line segment that touches only one point on the circumference of the circle. That is a tangent line. Not the same type of tangent line necessarily that you learned about that tangent function in right triangle trig. This is a tangent line. All right. Next here we have a portion defined by two radii, that's the plural of radius, and an arc. A portion, so a part of the circle, that's defined by two radii and an arc. Let's go look. Well, we already talked about a segment. That was a portion of the circle, but it was defined by a chord and the circumference. So our other portion is called a sector, defined by two radii. So there's radius number 1, and part of this diameter is radius number 2, and then the exterior arc here. That is a sector of a circle, defined by two radii and an arc. Two to go. Next, it says we are looking for something that is a portion of the circumference. It's part of the circumference, so it's on the edge of the circle. So remember, the circumference goes all the way around the circle. And we're saying we want just a little portion of that, a little part of that. That is called an arc. Okay, I want to write something down below, a little bit more information here, because you're going to hear these words too. You can have something called a minor arc versus a major arc. Okay, a minor arc versus a major arc. Well, a minor arc, minor means small, major means large. A minor arc is less than 180 degrees. A major arc is more than 180 degrees. So if you hear that adjective added on, minor versus major, that's what we're talking about. We're talking about something smaller than half the circle versus something larger than half the circle. Okay, let's see. We did arc in orange, or I did arc in orange. All right, and last but not least here, a line that intersects the circumference at 2 points. It's a line, it's not a line segment, so we're looking for something that continues on forever and ever. And that's our only vocabulary word left, is the secant here in blue. It looks a lot like a chord. Remember, a chord has endpoints. A secant continues on forever. Okay, so we've gotten through a lot of vocabulary words. I'm sure some of them you have heard before and others you haven't. So really just focus in on the ones that you haven't heard before. I mean, I know you've heard of diameter and radius and center and that kind of thing, but maybe some of these others are new for you. So really focus in on those so that we can be speaking the same language when we're talking about circles. All right, there's also a few formulas that you need to know here. That's our next thing. It says to fill in each formula. So let's take a look. There are 3 formulas here. The first one is for a diameter. So let's check out this diameter going across in green. Okay, the thing I want you to know about the diameter is that it's 1 radius plus another radius. It's 2 radii form a diameter. So we have D equals 2R. A diameter is equal to 2 times the length of the radius. Okay, another really important formula for you to know is this capital C stands for circumference. This is your circumference formula. Maybe we should write down what they are. This first one was your diameter. Okay, the circumference of a circle is 2 times pi times the radius. We're going to see a lot of pi in this unit. It's a very important number when it comes to measurements of a circle. And then finally, our last formula here is your area formula. And it also uses pi. It is pi times the radius squared. Okay, you've already done your area portion of the curriculum, so you are probably already familiar with some of these here. Also, good to know, all of these are on your formula sheet. Yay, less to memorize. All right, so the last thing to do is for you to make this your own. It says to highlight and embellish your key ideas. Really make this something that you can use as a study guide. Take a moment and embellish it. Make sure you understand everything. Come ask me questions if you have any, and then we'll continue. Ta-da, fun notes, looking good. Something easy for me to remember. All right, let's flip the page and let's get started on some more of the basics. Here, this was now we got all our formulas and our vocab set up. Let's move on. Okay, so our first basic measurement to know about a circle is called the central angle. So here's another vocab word for you. A central angle is an angle where the vertex is at the center of the circle. Okay, vertex right here at the center of the circle. This is circle B, and its 2 sides, the 2 sides of the central angle are radii. Okay, so our central angle is at the center of the circle. That makes sense, and it extends out down the radii. Okay, well, the sum of all central angles in a circle, if you were to add up all the different central angles that get cut up into a circle, you're going to have a total of 360 degrees. Okay, all the way around a circle is 360 degrees. All right, so let's take a look at this picture over here. We would call this central angle angle A, go down to the vertex at B, and then go back to the circle at C. So this central angle is angle ABC. Well, a really interesting feature, or a really important feature, is that the degree of this arc out here, remember, an arc is along the edge of the circle. So I'm talking about this arc out here. The degree of the arc is equal to the degree of the angle, the central angle. So we have a tool that can measure angles. It's called a protractor. We don't necessarily have a tool that can measure the degree arc out here. So we can use a protractor to measure the arc. So this 84-degree angle is equal to this 84-degree arc. Now here's your notation. This symbol down here says the measure of the arc. We're looking for the degree of the arc from point A to point C. So notice that it's curved. Maybe you want to embellish that and highlight that. Notice that it's curved. It's not a straight line. And we're just talking about the measure from A to C. Okay, well, what about going the other direction? Okay, what about going all the way this way? That's going from A to C. Okay, so in order to know which direction to go, we're going to need this third letter here. I went from A all the way around to D to C. Okay, to go from A to C is to go the shortest distance, 84 degrees. But to go all the way around from A to D to C is a longer distance. So how many degrees would that be? Well, remember this, guys. A circle is a total 360 degree around one revolution. So if there's 360 degrees in a circle and 84 of those degrees is being used for the smaller arc, then that's going to leave 276 degrees for the larger arc. Now, do you remember what those vocab words are that I was showing you about the arcs? We have two different arcs here. This would be called a minor arc. It's less than 180 degrees, while A to D to C is called a major arc. It's more than 180 degrees. So the minor arc here and the major arc from A to D to C. Let's do some practice problems. Directions say, find each angle and arc measures. So the only angle we're given in the entire picture is here, angle JNK. Angle JNK is 21 degrees. Well, with our definition of central angle, that means that the arc that corresponds with it is also 21 degrees. So that would be arc JK is also 21 degrees. All right, next we're asked for angle JNM. Angle J to N to M. All right, this is going to be a throwback problem. Angle JNM is a linear pair with angle JNK. Look how they're side by side. In fact, if you cover up half the picture, you only have half of a circle, and we know half of a circle is 180 degrees, just like a linear pair sums up to 180 degrees. So to find angle JNM, we can start with 180 degrees and subtract off the 21. That's going to leave us with 159 degrees. Okay. I'm going to write it on my picture. In fact, I can write this in two places. So I know that's my angle measure, but because central angles and their arcs are equal to each other, I can also write it out here on the arc. That would represent arc J through M. J through M, which is not something in my list that I'm being asked for, but that would also be 159 degrees. All right, let's see. The next thing we're being asked for is arc KL. Arc from K to L. All right, this uses some more prior information. So we also have, with this intersecting set of lines, vertical angles. So we just measured 159 degrees on the left, so its vertical measure is also 159 degrees, and because the central angle matches the arc, then this arc KL is also 159 degrees. All right, we're getting there. We got 2 more to go. Next, we're looking for, you know what, before we move on, we might as well go ahead and write that 21 degree here too, because we know the same thing's happening there, a set of vertical angles. So 21 degrees here. Finish that out. Now, next we're going to be looking for a major arc. Let's check it out. We start at J, go to K, and then go all the way around to M. J to K to M. Trying to match up my colors here. J to K to M is my arc in yellow. All right, well, from J to K to M uses 3 of the arcs that we've previously measured. So I just add them up. 21 plus 159 is that 180 plus another 21 is a total of 201. It's 201 degrees. And finally, our last one says we start at angle M, go all the way to K, and then go all the way to L. So check this out. M, all the way to K, all the way to L. Okay, so maybe you're asking, why did I go to the left? M to K to L. Well, because I don't want to overlap. Okay, our major arc is more than 180 degrees, but it's also within the circle. Well, here I'm using 1, 2, 3 different angles, and those 3 angles are the 159, then a 21, so there's 180 degrees, remember that's half the circle, and then another 159 degree angle. That totals 339 degrees for our final angle, 339 degrees. And that is the arc in blue. Hopefully these colors help you keep up with what we've been measuring. Okay, if you'd like to pause the video and try number 2, go for it. When you come back, I'm going to talk through a little bit faster, but I'm going to talk through how I find all these measures. Okay, so the first angle I'm looking for is UXV. U to X to V. It's not part of my given information. However, if you look straight across the angle, you'll find a vertical angle that has a measure of 72 degrees. So if this angle, if the vertical angles are congruent, then the arcs are also congruent. So that's also 72 degrees. Next, we're looking for ST. Well, check out the other piece of given information here. We've got 87 degrees hiding here. We've got 72 degrees here. If we use this ST in between them, we have highlighted exactly half the circle. And we know that half of a circle is 180 degrees. So if I take that 180 degrees and take off the 87 and 72, I'm left with 21 degrees for arc ST. All right, next I'm looking for arc WV. W to V. Well, it's the only arc I don't know now. I know all these other arcs. I'll label them 21 degrees, 87 degrees, and a couple 72s. So all the way around the circle, if I knew all the parts, that would add up to 360 degrees. And I almost know all the parts. I just need WV. So I'm going to take 360 degrees and subtract off everything I know. The 72, the 21, the 87, and the other 72. What I'm left with is 108 degrees for W to V. Now, if you were to add up each individual arc, it would total 360 degrees. I think now we can finish out and answer all the rest of our questions. The next arc I'm asked for is from T to W. From T to W uses two angles. It uses the arc 21 degrees and the arc 72 degrees. So 21 and 72 combined is 93. 93 degrees for arc TW. And last one, a major arc. Start at T, move to V, finish at W. T to V to W. Well, that uses the 87 degree arc, a 72 degree arc, and a 108 degree arc. If you add all that together, 87 plus 72 plus 108 totals up to 267 degrees. So we've taken our time to really try to understand what central angles are and how they relate to their arc measurement. I hope you can see that very clearly the central angle and the arc are equal to each other. We're about to apply some algebra skills to that. The concepts do not change. All right, so let's check out number 8 here. We have two arcs that have been labeled up with algebra. If you look at where they are, okay, they are side by side. I'm going to highlight them. If I highlight them together, it's very easy to see that they make up exactly half of the circle. And we all know that half of a circle totals 180 degrees. So to apply this theorem with the algebra, we would have to add these two parts together to total 180 degrees. And that would look like 5x plus 23 plus the second arc, 17x minus 41, is equal to a total of 180 degrees. You guys have been doing great with your algebra all year long, so I'm going to pause the video, solve, and you can check your answer. Okay, so you can see that I got x equals 9. If you did not get x equals 9, check out my work. The first thing I did was I combined like terms. 5x and 17x combined for 22 x's. Positive 23 and negative 41 combined for negative 18. So I have 22x minus 18 equals 180. Add over the 180 degrees. Divide off the 22 for a total of 9. So x is equal to 9. Now that I know the value of x, I can plug back in to find these other arc values. So let's take a look at our picture. Arc JK, that's the 5x plus 23. So arc JK is going to be 5 times our value of x, which is 9, plus the 23 degrees. Well, 5 times 9 is 45, and 45 plus 23 is 68. All right, next we're asked for MJ. Look at where MJ is. MJ is out here. It has no algebra associated with it, but can you find what it would be equal to in the picture? It has a vertical angle connection. it would be equal to whatever LK is. So LK is represented by 17x minus 41, and we know that x is 9 degrees. So 17 times 9 minus 41. 17 times 9 minus 41 is 112 degrees. Maybe you're thinking that could be done another way, and you're right. We said that it was half of a circle, and half of a circle adds to 180 degrees. So 68 plus 112 is that 180 degrees. We have one final piece. We're looking for the major arc from L to M to K. From L to M to K. Let's highlight that in blue. From L over to M, around to K. Okay, so that uses 3 separate arcs. We know that JK is 68 degrees, so its vertical arc would also be 68 degrees. And now we know that MJ is 112 degrees, just like its vertical arc is 112 degrees. So if I want to find L to M to K, I could just add up these 3 arcs. 68 plus 112 plus another 68 adds up for a total of 248 degrees. So LMK is 248. Okay, you have one more example to try here. I'm going to pause the video and I want you to see what you can do. Okay, first things first is, what on earth is the equation that I'm supposed to be solving? So check this out. In your picture, you have 3 pieces of algebra, and then you have one 90-degree angle. So remember that 90-degree angle can be transferred out to the arc. And now I have every single arc in the circle. Well, we know that entire circles have a sum of 360 degrees. So check out my equation. I've added up all the arcs, 90, 8x, 21x minus 12, and 10x plus 9, total up to 360 degrees. The setup is the toughest part. Once you get there, turn on your algebra skills, combine like terms, and isolate x, and I got x equals 7. Okay, I'm going to pause the video again. I want you to take that 7 and see if you can find these 4 arc measures. All right, let's check answers. I got the measure of arc WX is 135 degrees, the measure of arc YW is 146 degrees, the measure of arc YX is 79 degrees, and the major arc V to X to W is 304 degrees. Here's my plugins on the right. All I've done is I've taken the value of X, which we got as 7, and plugged it into the appropriate algebra. This was our first big part of the lesson, our second big part of the lesson. We know our vocabulary. Now we know our central angles and arc measures. We have a little bit more to go, so hang in there. Okay, on this next piece of notes, we have another type of angle we have to look at, and it's an angle that's called an inscribed angle. Inscribed simply means that the angle is drawn into the circumference of the circle. Inscribed, drawn inside. So, in my picture here, my inscribed angle is ABC. An inscribed angle is an angle where this time the vertex is not at the center. This vertex is on the circle. It's on the circumference of the circle. And the 2 sides are chords. They're not radii because they're connected all the way across the circle. Something very important to understand is that the intercepted arc, the arc that is created by the inscribed angle, lies between the endpoints of the inscribed angle. Okay, so for example, the arc that is created by this angle, if we use our endpoints are A and C. So the arc that goes with our inscribed angle is arc AC. Now the relationship between the two is different. They are not equal to each other as the central angles were. The degree of the inscribed angle is equal to half the measure of the arc. The angle is half the measure of the arc. So maybe you want a little formula over here. The angle is equal to half the measure of its arc. The angle is equal to half the arc. All right, so what would that do if the intercepted is the diameter? Okay, so let's take a look. If our inscribed angle, here's our inscribed angle again, highlighting it out, bolding it in purple. If our inscribed angle hits on the diameter, think that one through. You know that the diameter cuts the circle in half, so it creates 180 degrees out here. And if our formula says, or the relationship is, that the angle is equal to half the arc, then that means half of 180 degrees is 90 degrees. 90 degrees. So it creates a right angle. A 90-degree angle. So the diameter cuts the circle in half. There's your 180, half of the circle. And the diameter, the inscribed angle is half that value. So it's a 90-degree angle. All right, well, what about one more what if? What if you have some funky picture happening and you have more than one inscribed angle? All right, so I've got one inscribed angle, I'll highlight in orange. Okay, and a second inscribed angle right here, highlighted in purple. Well, something to notice about these two angles is that they both end at the same endpoints. So if two inscribed angles intercept the same arc, see how they're both hitting at AD, they both create arc AD. Well, if they make the same arc measure, then they must be congruent to each other. They must be congruent. So let's just say, let's say that that's 50 degrees out there on the arc. Okay, if the angle is half of the arc, half of 50 would be 25 and 25 for both of these inscribed angles. Maybe it wasn't 50. Maybe it was 60 degrees. Maybe it was 80 degrees. I don't know. All you need to know is that they're congruent so that their measures are equal. Whatever ABD is going to be equal to ACD. They're equal measures. Let's do some practices here and see if it can make some sense for you. All right, let's start with something pretty simple. One basic inscribed angle. The angle we're looking at is angle WXY. The arc that's created by that angle measures 62 degrees. Okay, now remember, the angle is equal to half of the arc. So we're trying to figure out what the angle is. I'm going to call that X. We know that the arc is 62 degrees. Half of 62 is 31. So our angle measure is 31 degrees. All right, let's switch it around. Check it out. Now we're not looking for the angle. Now we're looking for the arc. We are looking for arc D to G to F. It's a major arc. It's really big. Following the same pattern, the angle is equal to half of the arc. Well, this time we know that the angle measure is 113. What we're trying to find is the arc. So I put an X where the arc is. Okay, so how do I get rid of this 1/2? Well, I'm going to multiply both sides times 2, because half and 2 will cancel each other out. 113 times 2 is 226 degrees. I hope that value makes sense to you, because a major arc like this has to be more than half of a circle. It's a really big curve. All right, let's look at example 3. We're back to an angle. We're looking for angle P to Q to R. P to Q to R. Well, let's see what arc that makes. Starting at the endpoint P, travels around to endpoint R. Uh-oh, we have no number here. The angle is equal to half the arc. We're trying to figure out what the angle is, and we don't know what the arc is. So look at this picture closely. Look very closely. Notice that this line going through the middle of our page here is a diameter, and a diameter cuts a circle in half. So even though it's not written here, we do know that this is a 180-degree angle, and half of 180 degrees is 90. So our angle is a right angle. That goes back to this note here. Every single time an inscribed angle intercepts a diameter, it's going to be a right angle. Now you can imagine that you might have to do some right triangle work within a circle on a high-level problem. That could be a Pythagorean theorem question. That could be a trig question. Anything to do with a right triangle is valid. All right, let's finish out with some algebra here. Check it out. How is algebra going to get mixed into our circles? Well, question here says we want to solve for x. X is part of the angle. The angle, the inscribed angle, is equal to half of its arc. Okay, so we've got angle ABC. That angle is 7x minus 10, and it is equal to half of its arc measure. Now, we don't know the arc measure here from A to C, but we can find it. We have other arc measures that can help us. We know that all the way around the circle is 360 degrees. We've already used 92 degrees of that curve on the left and 162 degrees of that curve on the right. So if we start with 360, subtract away the 2 that have already been used up, the leftover will be arc AC. And I get 106 for arc AC. So I can plug that into my little pattern over here. 7x minus 10 is equal to half of 106. Well, half of 106 is 53. Move my 10 over, and I'll have that 7x is equal to 63. Move my 7 over, and I'll have that x is equal to 9. Look at that, mixing up your geometry and algebra yet again. You got to know your pattern so you can figure out how to plug everything in. All right, let's take another look. Check out example 12 with me. Solve for x as our set of directions. This time the x is out here on RS. Okay, but the inscribed angle is QRS. So QRS, that angle is going to give us the arc from Q to S. So somehow that 67-degree angle is going to help us out with our problem. Well, remember, an inscribed angle is equal to half of the arc measure. So if the angle is 67, then arc QS out here, Okay, we can multiply by 2 and get that arc QS is 134. So if this is 134 degrees, that can help us get to what we need to solve for x. Now I have 3 arcs on a circle, all 3 parts. Every piece has been written out. I know that they add up to 360 degrees. Well, I've already used up the 134. I've already used up the 120. Let's see what's left for our little piece of algebra. 360 degrees, take off the 120, take off the 134, and that's going to leave us with 106 degrees for our little slice of algebra right here. So now I know how to set up my equation. That 5x plus 21 is equal to 106. Move over the 21 by subtracting, and the 5x will equal 85. Move over the 5 by dividing, and x is equal to 17. That was a pretty high-level problem, number 12 there. You have to use what you know about the inscribed angles in order to find all the missing parts so that you can set up the algebra problem. I've got one final example for you. Let's take a look at example 17 here. All right, let's label our picture. If angle LMP here is 5x minus 19, and angle LNP here is 2x plus 11, find the measure of arc P to L. Looking for P to L. Well, I think what's interesting about PL is that it goes with these inscribed angles in our picture. In fact, it goes with both of them. If I follow the chord LM and PM, I've made the angle 5x minus 19. If I follow the other 2 chords, it makes the angle 2x plus 11. Well, if both angles create the same arc, then these angles have to be congruent to one another. So the algebra I want to set up here is that 5x minus 19 is equal to 2x plus 11. The 2 angles are equal because they create the same arc. Do a little solve here. Move over this 2x by subtracting. Move over this 19 by adding. 19 and 11 make 30. 3x is equal to 30. Divide by 3 on both sides, and I'm getting x is equal to 10. My final step is to use that 10 to solve for PL, arc PL. Well, if I plug 10 in to either one of these angles, I'll know the angle measure. This one looks easier. 2 times 10 is 20, and 20 plus 11 is 31. Now our inscribed angle pattern says that the angle is equal to 1/2 of the arc. So the 31 degree angle is equal to 1/2 of PL, arc PL. So I need to multiply by 2. 31 times 2 is 62 degrees for the measure of arc PL. Whew, inscribed angles. They're all over the place, but they're such a good study. All right, guys, you have gone through what I consider the basic pieces of circles. There's so much to learn about circles, but these big ideas, the vocabulary and the central angles from page 2 and the inscribed angles from page 3, that is really the meat of the lesson. There's a lot more about circles coming up in the next lesson. However, I am going to allow you to opt out of that lesson if you want to. The math is tough. The formulas are tough. And we don't see them much in future math classes, nor do we see much of it on our SOL test. So go for the advanced lesson if you feel like a challenge, or move on to arc length and sector area if this is challenging enough for you. Happy studying.